guys. This is for module 14.2, Law of Cosines. Now, our essential question is how can you use the law of cosines to find measures of any triangle? Keyword any, right? So it's not just right triangles, you could use it for non-right triangles. So our shortest answer is basically we can use this law of cosines to solve triangles, all right? Basically, we can use them to solve their angles, we could have them solve our sides, etc. As long as we have a side angle side or side information set in our problem. Okay. Now, if you remember, law of sines did not use side angle side or side. It was what angle side or side angle. So be aware, not not one rule is not going to be used for every single type of problem. Okay. Certain rules for certain problems, just like a tool. You don't use a hammer to um, uh, I don't know, file your toenails, right? You don't use a hammer to file down your toenails. That's my grandfather would probably use a power tool, but pretty sure that the void warranty says not to do that. But hey, old people, they're awesome. All right, so deriving the law of cosines, deriving the law of cosines. Now, I usually teach thinking that I'm teaching you how to slay monsters, and monsters are just math problems. But nobody ever asked about where the monster comes from, right? And I think Shrek was a really good example of a movie that's like, hey, we always see this monster in the movies, but we never really have a movie about the monster. Well, here's the movie about the monster. Now, to let you guys know, I am deriving the law of cosines. I will be using the idea of symmetry. Okay, so or not symmetry, similarity, keyword. All right, and we already know from this picture that triangle ABD, that little guy, will be similar to triangle BCD, and it will be similar to triangle ABC, the big triangle, right? But they're all similar, okay? So we've already learned that. And now we're going to use this idea to kind of come up with deriving the law of cosines. Now, one thing's for sure is law of sines. Um, it relies on angle side or side angle, but law of sines cannot be used for side angle side situations or side situations. Instead, we have to use the law of cosines. So in college, especially, I would see a certain problem and go, "Oh, isn't that the law of sines?" And I would try it, and I wouldn't be able to get my answer. And then all of a sudden, I stop and go, "Oh, wait, it's the other law of cosines." So there's a lot of that happens, okay, especially in college, no joke. Now, deriving it, we're actually going to derive um, using Pythagorean theorem. So we're going to write the relationship for the side lengths, okay, meaning for the hypotenuse for ABD, which is C, and the hypotenuse for A, okay. So these two triangles are similar, and we're just going to go ahead and find their side lengths. So we already know, let me start with the small guy, or actually, let me start with A, alphabet. We already know A squared is going to equal um, this base, right? B minus X squared plus, looks like this altitude here, H squared, right? That's Pythagorean theorem. Now we're going to solve for C. So, and C was going to be C squared equals X squared, right? That base, plus H squared, okay? So that's Pythagorean theorem. And now I notice, hey, this right here, b minus x squared, kind of reminds me of like expanding and multiplying binomials back in algebra 1. And that's true. So we're going to actually expand and multiply. So why? Because I want you to see something. So we're going to get b squared, right? Oops, I should probably expand first just so you can see what I'm talking about. That way you don't go to college and the teacher asks you to expand and all of a sudden you're just like, what does that mean? All right, so remember squared means that binomial is multiplying itself again. So b times b squared. B times negative xb, which there's two of them, so negative 2xb. And then negative x times negative x, positive x squared, super. And then we have that h squared, right? All right, so now it's looking really crazy, and you got some craziness going on. All right, but real quick, what do you guys notice? Right? That's coincidence? I think not. So c squared. Okay, so that basically they're just saying, all right, just substitute that in for c. So you're gonna have a squared equals b squared minus 2xb. But instead of the plus x squared plus h squared, right, which is pretty insane to remember, I mean, ooh, right, we're just going to say, nope, plus c squared, because c squared is x squared plus h squared. All right, so we're getting closer and closer to our rule. So following this guidance here, in the smaller triangle, triangle ABD, cosine of A, remember cosine is adjacent, which is x, over the hypotenuse, which is c. So we should already know that cosine of A equals x over c. So we're going to go ahead and solve for x, all right, which means we're going to isolate. So again, what's the opposite of dividing by c? Multiplying, right? And what you do to one side, do the other. So x will inevitably be c times cosine of whatever angle A is. So if we go ahead and substitute that down in there, for x, all right, that x, right, we're going to get a squared equals b squared minus 2. And let me make sure I line this up right. Um, minus 2b, because again, that b right there, right? So I'm just staying alphabetical here. And then this part, c of cos times cosine of angle A plus c squared. All right, so it's getting a little bit more formal here, and inevitably we get the equation here. So it's basically there, but in this situation, you would probably see or remember the law better if it's a squared equaling b squared plus whatever c squared is. Oops, sorry. Minus the 2b times c times cosine of angle A. So that would be where the law of cosines comes from in that situation. Now, basically it's like this, and I'm going to clean up this picture, all right? And let me kind of explain. So in the box down here, the equation that I just derived, all right, it's basically at the reference of angle A, right? Angle A. So here's angle A, right? And angle A is trying to figure out, dang, who's that? Who's that A over there? I'm interested in that person. And then basically what angle A has to do is talk to the side A, the other sides. Like, yo, B, what's up with A over there? Yo, C, what's up with angle A over there? And the angle A has a certain degree. So basically it uses the two other sides and its own angle to kind of figure out A. So it's kind of like, let's see, teenagers, drama, things like that. Okay, so basically your angle A, all right, that's you. You already know that you run at a certain degree, and you're really interested in that person across the hall or across the campus, or you just like you're just staring at them nonstop. Like, dang, they're interesting. But you usually talk to their friends first because you're a high schooler, and that's usually how high schoolers operate. And then you kind of go to figure out A. That's basically law of cosines. You're using their two friends, and before you even try to figure them out. Okay, awkward. I know. High school. So again, here we go. Here is the rules, all right? The red one will be for this situation. Your angle A, you're interested in finding out who that person is over there on the other side, all right? But you have to talk to their friends first, okay? So here are their friends, right? Got their friends all together. Here's you, and you're trying to figure out who A is, right? Now, let me this situation is the same law of cosines, but basically it's like this. Your angle B, you have the Haas for the person across there, right? And you decide to talk to their two friends first before you approach them. Now, the other situation is your angle C. You have the hots for the person across, but you're a high schooler and you're going to talk to their friends first. That's basically the situation, as simplified as possible. All right, so example one. Here we go. You are angle B. You are attracted to the person across the campus or whatever. Now, you do know you are 100 degrees, all right? And B's friends are 5 and 7. So we're going to go ahead and set that up. Now, who do you care about? You care about B, all right? So B squared equals, in this situation, A squared plus C squared minus 2 times AC times the cosine of whatever angle B is. Now, B squared is who you care about. That's who you're trying to figure out. You know their friend is one of their friends is 5. Their other friend is 7 minus 2 times 5 times 7 times cosine of angle B, which is 100 degrees. Now, here comes the crazy part. A lot of this is just calculator based. 5 squared is 25. Don't forget this is B squared. This is 25, right? Because B squared is, or 5 squared is 5 times 5, and 7 squared is 7 times 7. We have negative 2 times negative 5, or positive 5, that's 10, negative 10. Negative 10 times 7 is negative 70. And then we have cosine of 100 degrees. All right, so in your calculator, 100. Yeah, let me go ahead and combine the constant terms. 25 plus 49. We're going to clean this up a little bit. You should have gotten 74. All right, and don't forget we're still solving for b squared minus 70 cosine of 100 degrees. Now, in your calculator, 100 cosine equals, and then times, I'm sorry, 100 cosine, and then I think times. Don't forget it's technically negative 70, but just remember the subtraction, okay? So let's see. Well, we could do 74. If you have one of those really good calculators, on the scientific ones, you can just type in this whole line right here, 74 minus 70. Don't forget to use parentheses correctly if you have one of those calculators. Be careful with that if you're confused about what I'm talking about. Just have one of those calculators and you can show me. All right, so we got b squared equaling 86.15537.244. Now, I'm not going to reduce yet. In my calculator, I'm just going to press square root of my answer. All right. So let's see. Square root of my answer. And I get, for B, I get 9.2819. I'm just going to round to the nearest tenth. Look at that. Even after all this mumbo jumbo, I still have to pay attention to the instructions. So it looks like my answer is 9.3. That was the horrendous 3. Wow, I really messed up on that 3. Okay, there we go. All right, so again, that was law of cosines. Double check your calculator, make sure you know how to plug that in. All right, example 2. Here we go. Uh-oh. What we don't know an angle. We don't have an angle at all. We just have side, 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 right? So, how about this? I'm going to go ahead and I want to find angle C first. All right. Now, please note, if you go back to the last problem, I didn't solve for the other two angles, right? It said solve for triangle ABC, but I didn't get A. I didn't get C. So what I could do here is if I want to solve for, I don't know, angle A. All right. So yes, I'm kind of going backwards. My bad. We're gonna have to set up the law of cosines to figure out angle A. So That's in reference to cosine of A. So if we set that up, the guy across is 7 squared. So we already know the person over there, it's 7 squared. Okay. Um, and we know we should equal that to their two friends, which is 5 squared, plus what we just found out to be 9.3 squared. So you kind of change your mind on who you thought was hot or something. I don't know. And 2 times the 5 times the 9.3, which is going to be times cosine of A. Now, if you notice, the only missing variable you have in this setup is the angle itself. So let's go ahead and clean this up. We got 49 here. We got 25 here. 9.3 squared. You got 86. And I know what you're thinking, Mr. Webb, this is really messy. Like, there's a lot going on. And I agree. This is as crazy as it gets. Now, don't get me wrong. When you take trig, it gets more interesting. All right. So we got 9.3 times that 5 times that 2. Don't forget it's that subtraction, right? And oh, no way. Well, that turned out nice. That was like minus 93. And then don't forget it's multiplying to cosine of A. All right. Combine like terms. Let's get that away. Taken care of. So 86.49 plus the 25. And you get this mess, 111.49. And don't forget that 49's over there. Minus 93 cosine of A. How do we get rid of, I'll tell you what, I don't like that negative 93, so I'm going to move this whole chunk over to the other side, because I can do that like a boss. There we go. Whoa, thank you, pen, for doing whatever that was. Not my CPU, that's for sure. All right, so we got 49 plus the 93 cosine of A, and I really feel like I should just subtract that 49, but I'll do that next. Equaling 111.49, subtract the 49, okay. Ultimately, what I'm doing here, guys, is I am isolating A, all right? So follow along with me, 111.49 minus 49, and you should get 62.49. Very nice. And then 93 cosine of A. How do you get rid of a multiplying 93? Divide. So I'm dividing by 93 there. Sorry if it's at the bottom of the screen. So we have cosine of A equaling 62.49 divided by 93. You should get 0.6719354839. Now, the reason I'm not reducing is because inevitably I'm going to type in my calculator the inverse of cosine. Why? Because I'm trying to look for an angle. So that's the same, all right? So when you have that 0.61935 blah, 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 blah on your calculator screen, go ahead and press second cosine, all right? So when you do that, you should get, for angle A, 47.7. I'm going to round to the nearest, 48 degrees. All right, because you should have gotten, again, 47, approximately 47.783, something, something, something. All right, but I'm rounding to the nearest. Now, if this guy is 48 degrees, and we already have 100 degrees from B, that's 148. And basically, it's 180, right? The triangle sum theorem minus the 148, and you get 32. So angle C is 32 degrees. All right, so I did solve for the whole triangle now, okay? So if you notice, that's the law of cosines, that's the law of cosines. It helps you find not just side lengths, but also for angles. So be aware. And this was all based on side angle, side similarity, okay? Now, in college, I would see that real quick, and I would immediately go, oh dear Lord, that is cosines. I got to use cosine. Okay, law of cosines. And that's where you need to be by the time you get to college. All right, example 2. Um, let's solve for the rest of this triangle. So again, it's side, 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 right? We have nothing but sides. And we're going to go ahead and use cosine of C. So again, who's that person across the way, right? Equaling their friends, right? So we got 10.5 squared plus 6.3 squared minus the 2 times 10.5. So you're getting their friends together. Maybe take them out on a coffee date, get to know them, be like, hey, you're both friends with that one person. And then, so that's basically how I always imagine high schoolers to be. Too scared. I'm scared. All right. So we got 12 squared, which is 144. And I wish I could be a boss and do decimals in my head like that. That'd be great. But I had a long day. Oh, yeah. I love it how you see something, type it in, and you see the answer, and you're just like, oh, my brain could have done that. Why doubt myself, right? 6.3 squared, you should get 39.69. And then minus the 2 times the 10.5 times the 6.3. And you get 132.3 times that cosine of C. And if you notice, the only variable that we don't really know in the formula is C. So we're going to solve for angle C. All right, let's combine like terms. Let's do that first. All right, so we got 110.25 plus that 39.69. And you should realize we get 149.94. All right, don't forget it's still equaling the 144 on the left-hand side. And we still have that minus 132.3 multiplying that to that cosine of C. All right. All right, so let's go ahead and move some things around. I'm going to add, oops, I want to add that whole term. And remember what you do to one side, you do to the other. Oops, sorry. Getting sloppy there. Silly numbers. Silly hand. I'm going to blame everything on my hand now. All right, there we go. And then don't forget that 144. I'm going to go ahead and move that 144, just to give you guys a heads up. Now, how do you get rid of a positive 144? We subtract, and then just remember what you do to one side, you do to the other. All right, so just be aware I want to be doing that to get rid of that. So here we go. These canceled out. We have the 132.3 times the cosine of C equaling, again, 5.94. All right, that worked out good for my head. How do we get rid of a multiplying 132.3? We divide. So still using the properties of equality, and I really need to learn what that is. It's driving me insane. There we go, 132.3. And then what you do to one side, do to the other. Property of equality. All right, those cancel out. And now all we have left is cosine of C equaling, and I'm going to go ahead and use the calculator, 5.94 divided by 132.3. And you should get something redonkulous, 0.0044897. And I know what you're thinking, do I really have to write all this down? No, but I want to make sure you do not round this until you press. Now, how do you find the angle? You use the inverse. So once you have that huge number, press second cosine, and then you should have that already on the screen, and you should have gotten for angle C 87.4. I'm going to round to the nearest, so I got 87 degrees. Now, one thing I love about this kind of problem is you're not solving for any missing sides, just the angle. So it's like I want to use two inverses, get two angles, and then use triangle sum theorem to get my last little piece. So that's 87 degrees. Very nice. All right, and it looks I'm still stuck with side angle side. So that's still using law of cosines. It's like, can I use law of sines at least? Jeez, right? Um, hmm, that's interesting. So now we have to solve for angle B. Luckily, so basically this was like the first half of the whole thing, and the second is finding angle B. All right, so that was for angle C, and this part is going to be for angle B. All right, so angle B. Let me go ahead and do a nice color coding here to kind of simulate what I'm talking about. I want to choose purple. All right, so here's purple. Angle B, the opposite guy over is 6.3. So you already know the person that you're attracted to, and you already know their friends is 10.5 squared plus the 12 squared minus the two times you had to take them both out to Starbucks to talk to them about their mutual friend, right? And then times cosine of who you are, angle B. Sorry, there we go. All right, so basically it's like this. 6.3 squared, we already got that in the calculator as 39.69, again from up here. And then with a 10.5 squared is the 110.25, the 144 from the 12 squared minus the 2, and dang, it's slightly different. So 2 times 10.5 times the 12, right? And you should get 252 times the cosine of angle B, because that's what we care about finding, right? Combine like terms, let's go ahead and take care of that. So we got 39.69 combine like terms. So you should get, let's see, 144 plus 110.25. Notice how you just kind of hear me clicking all these numbers because calculators help do a lot of the legwork for you, especially when you're tired. And you should get 254.25. And don't forget minus the 252 of cosine B. Okay, sorry, penmanship is getting sloppy. All right, let's move on. Isolating our variable. I just do not like that negative in front of that term, so I'm going to just add it. What I do to one side, we do to the other. All right, so those cancel out. So I got 252 cosine of B. Wow, that was the worst B in human history. Plus that 36 point, or not 36, that 39, sorry, 0.69, equaling that 254.25. Now, let's go ahead and get rid of that 39.69. Just remember what you do to one side, you do to the other, so I'm subtracting. I do not know why I wrote 36 again. There we go. Cancels out. So we have 252 times cosine of angle B equaling, again, 254.25 minus the 39.69. You should get 214.56. How do you get rid of a multiplying 252? Divide. Just remember what you do to one side, you do to the other. So we have cosine of angle B equaling 214 divided by 252. And you should get something large and outrageous as 0.8514285714. And I know you're like, why do you have that? But by now you realize it's because you want to be as accurate as you can and using second cosine. So second cosine of that in your calculator and you should get 31.6, right? So angle B, I want to go ahead and round. Okay, so again, you got approximately 31.6. I want to go ahead and round to 32 degrees. All right, so B is 32 degrees. And again, what's wonderful about remembering the triangle sum theorem is you do not need to do the law of cosines again, unless you really want to torture yourself. I mean, be my guest. Beauty and the Beast should have been about doing math problems. Be my guest, be my guest. All right, so we have 180 degrees minus the 32 degrees minus the 87 degrees, and you should get 61 degrees for angle A. There you go. We just solved for the whole triangle, and it was mostly just about the angles, right? So still using inverse operations for the trig to find the angles. So there you guys go. Now your turn number one. Looks like we got a side angle side situation. Solve for each triangle, round to the nearest tenth. So let me explain. I do recommend finding Q first, then angle P, then angle R. So there are three things you have to solve for. So again, look at the examples. Who are you, right? Your angle Q. Who's the person you're attracted to on the other side? Who are their friends? And that kind of helps you set up the formula. The rest is algebra. All right, your turn number two, same deal. You want to find out who P is first. That's my recommendation. Again, who are you? And then who are their friends? And then set up the formula. All right, the rest is algebra. So again, if you guys have any questions, let me know, and good luck. Here is your homework. Again, if you did the problems in the your turn, if you understand it, you're gonna look at the homework and go, "Oh, that's cute." Okay. And just to give you guys a heads up, I know this one was a doozy. I'm scared to actually even look at the time on how long this video took me. Um, but I want you to know, if you love challenging yourself as a human being, this is just a one step in the journey in the right direction. And I think if you are serious about just growing up as a person, this teaches you integrity. And most of you already have it. You've shown it to me. And I think you guys just need to keep going. Do not stop. You guys are young, you have time, and I think you just need to take advantage of that time. So don't zone out. Don't get distracted by cell phones and all that stuff. Just keep stepping, because, even if you stumble a little bit, that's fine. All right. Nobody learns how to get up if they never fail, right? So keep going, don't stop, and good luck.